In this class, we're going to learn what is the annuity and how do we convert the annuity to P and F. Okay, so what is the annuity? Think about that. If you save the same amount of money every month in your saving account, that same amount of money every month, that is annuity. Okay, that's a uniform series of cash flow going into your account. Or if you got a paycheck from your employer, okay, basically you're gonna have the same amount salary, okay, right? And that same amount monthly salary is gonna be annuity. That's what we call an annuity, okay? So by definition, the cash flow diagram of the annuity will involve a series of uniform or equal receipts. It could be receipts, it could be expenses. It's just the same amount of cash flow occurring at the end of every compounding period. Okay, and we call each of amount annuity. So letter A is for annuity. Okay, and like what I said, that annuity cash flow should occur at the end of each period for n periods. So it occurred at time point 1, that's the end of the first month, or no, I mean the first period. And then at the end of the second period, and then go on until at the end of the nth period. Okay, so the annuity always occur at the end of the first period and end at the end of the nth period. So this graph is a typical graph for annuity. Okay, so you will see the same length of arrows at the end of the first period, the second period, the third period, the n-1 period, and also the end of the n period. They are the same length, which means they are the same amount. Okay, and then you label them the same amount. Here we label it as A, but if you have a specific amount, you just label it here, maybe 100 every month, okay? Or you can also just write A equals to 100, and everybody will understand, okay, that's gonna be 100 every period, okay? So that you don't have to write the 100 like many times. And also, if you want to draw this type of diagram, you need to label out your I. Maybe your I is 10%. You just write it either beneath this timeline or above. Okay, and usually our problem will be to find out the present equivalent of this annuity, okay? Or we want to find out the future equivalent of this annuity, okay? And I would say you're going to convert the annuity back to the present time, or you want to convert the annuity toward the future time. That's the way I say that, but it is to find out the present equivalent and the future equivalent of the given annuity. Okay, and then let's take a look at these green boxes. So the timing when the annuity occur is very important. It is always at the end of periods 1 through n, including n. Okay, so if you have a cash flow diagram. Let me draw it here. If you have a cash flow diagram, okay, 0, 1, 2, 3, 4, 5 years maybe, but your annuity occur beginning at the end of the second period, like that, and you don't have anything in the end of the first period or in the end of the fifth period. Although we can say these three are still annuities, but you cannot use the equation we're going to introduce in a later slide for this problem. Why? Because it doesn't follow the rule, okay? The rule is to use the method we're going to talk about later. You need to have your annuity begin at the end of the first period, okay? Which means you need to have something here. And also you need to have it through the end period, including n. So you need to have something here. In that case, you can use the equation in the next slide. Otherwise, it's another different problem, okay? So be careful about this thing. And always check on the cash flow diagram if you have that annuity at the beginning. I mean, in the end of the first month. Okay. And the P always occurs one interest period before the first A. Okay? So that's just one period before. And then the F is always at the same time as the last annuity. So when you get your last annuity, that's where you can calculate the future value. Okay? So let's just see what kind of things we can do to use the relationship between the annuity and the future value and the present value. So there are 4 things we can do. And so the first case is finding F given A. Okay? So find the future equivalent value given annuity. In the real case, you can think, suppose you start to save $500 every month into your bank account. So $500 every month into your bank account, that's kind of annuity, right? And after 5 years, which means after 60 months, how much you can get out from that bank account? Okay, so that's a typical question we ask ourselves. If I save $500 every month for 60 months, given the interest rate of 2%, then I want to know like how much I can get in after the 60 months. Okay, so to answer that question, you can use the equation for finding F given A. Very useful, right? The second scenario is to find P when given A. Okay, so suppose your parents want to put some money now to the bank account for your college life, okay? And what they want is you can get $500 every month from that account for 4 years for your college life. So you can get like $500 out from that account, okay? But to have that $500 every month, your parents need to put some money at the beginning in the account, okay? So they want to know how much they need to put into that account, because there is interest rate of 2%. Okay, so the way they can answer the question is they want to use the method to find the present value given that annuity. Also very useful. And then the third scenario is to find the annuity when given a future value. Okay, suppose you need to save same amount of money every month for your retirement insurance plan, right? That's what we do. You save some money into that insurance plan, and then when you got retired, you can withdraw a lot of money from that insurance plan. Okay, so now you're planning on that, and then you say, okay, my plan is to get 1 million after 30 years hard work in the company. And then, so you got a future value you want. That's 1 million after 30 years, right? And then you already know that the insurance plan, on average, it will give you the interest rate of 5% every month. Okay, so the question is how much you need to save to your insurance plan every month so that you can get 1 million after 30 years. Well, to answer this question, you need to use the equation of finding A when given F, which is very, very useful for me. The last scenario is to find A when given P. Okay, think about that. Suppose your parents now they put 50,000 into your bank account, okay, now, and they told you that that's all for your college life, okay? So there are not more money they can spend on you. They just have that 50,000 now. So they put that in the bank and they tell you that, okay, that's all for you, for your college life. So now you need to decide how much you want to withdraw from that account so that the money can be enough to cover the whole 4 years in the college. Okay, so now you want to know how much you need to you can withdraw. You cannot withdraw like 10,000 every month because that's the money is not enough. Okay, so you need to have a plan. And then to answer this question, you need to use the equation of finding A when given P. So these 4 scenarios are all very real and very useful in our daily life. So I think we have a very good reason to just learn how do we calculate the F given A, how do we calculate the P given A, how do we find out the A given F, how do we find out the A given P. So here are the equations. Of course, you can use the equation method. Okay, so to find the F given A, you can use F equals to A blah blah blah. But to look at this equation, it's just hard to calculate. Okay, hard to remember and hard to use. But luckily we have the factor method. Okay. So the factor method is easy to use, but the first thing is you need to learn how to write the factors first. Okay, so now let's just repeat how do we learn it, how do we write it. Okay, so the factor, you always want to put parentheses first, and then you think about what do you want to find. That's the letter at the beginning. So in this case, you want to find F. So it's F, and then slash, and then you put all the given conditions after this slash. And then so it's find F given what? Given A. So it's A, and you always know the interest rate and then the number of periods. That's how you write it, okay? Now let's practice this factor. So write the parentheses first, and then think about what do you want to find out. you want to find out the present value given A. So P is going to be the first letter and slash. And then after that are the given conditions. So you are given A and I% and N. Okay? Now let's continue to practice this. So for the third scenario, you want to find A when given F. So you want to put A at the beginning, slash F. And then you also know the interest rate and number of period. Okay, now let's try this. So the case is you want to find A when given P. So A is the beginning letter. And then next, given P and I% and N. Okay, practice this. Pause on this slide and then try to write down the factor on the paper and compare if you got the same answer. Okay, that's very important. All right, and then okay, so after you know how to write this factor, the way to calculate the F given A is very easy. So F equals to, because you are given A, so it's A times that factor, okay? And to find P when given A, so P is given, you are given A, so you put the A at the beginning, so A times a factor, okay? So if you want to find A when given F, so A equals to, because you're given F, so you put the F here and times that factor. And the same thing, if you want to find A when given P, so A equals to P, which is given, times the factor. Okay? And the way you find out the factors is the same. You first need to identify what interest rate. So you find this table from the Appendix C on your textbook, okay? And then you want to find out what is your question, what is the column. So if you want to find the F given A, you want to look at this. If you want to find out A given F, you want to look at this column. And then you're going to check the number of periods to find out which row you're looking at. And then you lock the factor value.